welcome back to Getting Started with Win2D. Well, this is episode 3, and in this episode our goal is to create a object called GenericItem. This is basically our basic building block, such that we don't have to give a starting location XY each time we want to draw. This object will contain the bitmap. It will contain the location where to draw it. It will also have a nice little bounding rectangle, so we know which area of the screen is actually taken up, and it will contain a draw and update function. And what I'm trying to do is create a item that we can use in the next episode, which we will probably define a scene. And what a scene is just a collection of generic items. So let's get started, shall we? Okay, so here we are in Visual Studios again, and this is the project that we left off in episode 2, I think. Just to make sure, let's see what it does. Yeah, this is the exact same project. Alright, so what we're going to do is first get rid of all this, because we won't be needing it, and let's get rid of all these simple drawing functions as well. There we go. Now it's pretty clean. It has a flag, we're loading some images here, and then we have a draw function. Alright. Okay, let me see. Now we want to scroll down to our share project, and that's where we usually will add in most of our custom objects. So add new item, Visual C# code class, and we'll call this GenericItem. As always, change the namespace, and I'll make this a public class. So let's think about the generic item for a minute. What do we need? Let me see. We probably need a name. Definitely a location to draw. The bitmap to draw. Maybe the size. And I definitely need something called a bounding rectangle. Okay. Then we probably need a update to update the object, and of course we need a draw function. Alright, so let's add in some namespaces that we probably need, which is the Microsoft Graphics canvas. Alright, so we'll define some properties, and the first one looks like we need a name, like that, and there we go. The location, let me think about this. Okay, in regular Windows you have a point, but we're gonna use a vector 2, so we probably need to add in system numerics. Vector 2 location. There we go. The bitmap will be, of course, the canvas bitmap. And the size will be I think in Win2D it's called bitmap size. Like that, and the bounding rectangle. Can I just actually it's probably yeah, so it's a Windows Foundation rec, so let's add in that as well. Foundation, so we don't have to do any of this junk. So bounding rectangle. Okay, we got that. So to do, we need an update and a draw. First, let's create a generic constructor, and we probably just want some of that. Okay, so basically you create the generic item, you give it a name, and we'll just default to empty string if they didn't provide anything. Alright, so the update. Alright. So the update would probably do a void, and we want a time span. Update the generic item, and dt is the delta time. Delta time since the last update was called. Okay. Now public void draw. Okay, we've done the update. For a generic item, you don't have to really update anything, I guess. So in the draw, we probably need a canvas drawing session, just like the draw function in the main page file. Okay, there we go. Draw the generic item and a surface. Surface to draw on. Okay, there we go. Well, that was easy. Okay. So if this is a basic building block, we probably want to make these virtual. So anything that uses this as a base class can define their own update and their own draw. Okay. Okay, so basically in our previous episode we drew the bitmap like this, I think. Draw image, and then the bitmap. In this case, this is just going to be bitmap here, and we just gave it a location, which is going to be here. So that's that simple. But we have to do some error checking first. So let's check to see if the bitmap is null. You know, probably want to return nothing. And that's about it, right? Yeah. Okay, so let's give this a try in our main page example.cs. For now, we're just going to create a generic item up here. New generic item. And I don't know, just test or something. Right? Okay. Here we need to set the bitmap of the generic item we just made. So we can either just set it from the return value in one of these, or we can set it from the image dictionary we made for the previous episode. So I would rather have a function called public bool set bitmap from image dictionary, and then give it a key that you want to search. Now, image content pipeline, and then we do like the previous episode. We'll try to get the value of the key, and it needs a canvas bitmap. Okay. If it's successful, then set the bitmap equal to CB, and return successful, else return false. Okay, so this basically sets the bitmap to a key value out inside the image dictionary. So we use a lot of stuff that we programmed last time. Okay, so our generic set bitmap, and I will set it to Canon. Yeah, and of course in the draw function we just call draw, and then we pass it the canvas drawing session. So that simplifies everything. Let's see what happens. And there it is. The default location will be 0, 0, way up in the top left. So let's move it somewhere over here. So we'll set the location to a new vector, I don't know, 400, 400. Make it look at the screen. There we go. That's something we can work with. Now, the last episode I was having troubles actually telling what part of the screen was the starting location and the width and the height of the bitmap. So this generic item should solve that. So let's calculate all that stuff. Okay. So when you set the bitmap, you should also set the size, because you know of the dimensions. So this dot size is equal to this dot bitmap dot size in pixels, I think. Yeah, there we go. Now we know the size. We know the starting location. Then we can figure out the bounding box pretty easily by just doing a kind of like a intersection or a union or whatever it's called. So we just create a new rectangle, and it will be location.x, location.y, and then the size dot width will be that, and the size dot height. That will be the bounding rectangle, like this. Okay. It doesn't have a set because the bounding rectangle is determined by whatever bitmap it is currently is. Okay, so I want to draw this bounding rectangle. So let's have a, like back in episode 1, we learned how to draw a rectangle. There we go, draw a rectangle. Bounding rectangle, and then we just gave it a color. Alright, let's go purple this time. So what we should see, hopefully see, is the image plus the rectangle that the image is currently taking up. Okay, so that looks really nice. Now I know that this is actually the real starting location right here on the top left, and this is down here, is from here to here is actually the whole bitmap. Okay, that looks really nice. What I want to do is I want to correct the bounding equation just a little bit, because this should be really -1 and height -1 as well, because let's say you have a bitmap that's only 10 in the width, then you want it to go not from 0, 0 to 10, 10. You want it to go to 0, 0 to 9, 9, because the width is actually let me see, total length is equal to endpoint minus starting point plus, you have to do a plus 1. So if you minus 1 from here, then we have our bounding box. That's basically what it comes down to. Okay, but I don't want to draw the bounding rectangle all the time. So let's create a variable or a flag for that. So public boolean draw bounding rectangle, right? There we go. And let's set this to false. Right, and then only draw it if only draw the bounding rectangle if the flag is set. So right now we shouldn't draw it because its default value is false, and it is. Okay. Now that we did that, we can just create a array of images and just plot them all on the screen. So let's do that. So go back to the main page. Okay. So I've got lists of generic items. We'll call this objects equals like that. And what we're going to do is we're going to create a whole bunch of them and then insert it into this list. Excuse me for a minute. And for now we'll create like let's do 50. So for loop and create a generic item. Then let's, for the life of me, let's just go I times 2 on the start location and I times 5 on that. Set it there, and then we just will add it to our list like that. So then we have 50 cannoneers inside this list of objects, and all you have to do is, of course, in the draw function, for each generic item in the list, draw. So, and let's see what this looks like. And there it is. It just makes this huge array of cannoneers, one overlapping another. So just for the fun of it, let's try to randomize the location for the X and Y. Okay. Okay, yeah. So we'll create a random variable here, and then I think it's called R next, and I want an integer. So from 0 to I don't know, let's try 1000, and then we'll create another one for the Y location, 0 to 800 would be pretty nice. Now we should see just the cannoneers everywhere. Okay, that's pretty good. Set it totally, some of them are off the screen. The Y value, oh yeah, of course, 8,000. I'm sorry. Let's make that 800. There we go. Now we have a bunch of cannoneers. So, for it to basically blit all those sprites onto the screen, it did it pretty freaking fast. So on in the start of the video, I always show this top-down shooter game, and what that game is It has 10,000, I guess, enemies, and then about 200 player units randomly moving, and some of them are shooting other things and stuff like that, and it gets such a good frame rate, and it's all updating in real time. So Win2D is extremely fast. I mean, it probably it is slower than Direct2D, which is the what we are using to wrap around. But yeah, it's, see, the speed on this is amazing. And if you're used to Windows form programming or Windows Win32 programming with the device contacts, once you do Win2D, you'll be amazed on how extremely fast this really is. So let's recap here, okay? We created a generic item that we can use, and the generic item is basically the building block for almost everything we're gonna do in the future. It has the update function, it has a draw function, and of course it has the draw bounding rectangle, which when you're designing a game or application is extremely useful. Then you can set the bitmap to anything you like that's been loaded inside the image dictionary that we did in the previous episode, and you set the location. So basically what we did is we packaged up all the stuff we have been doing into a simple class, and what happens is our draw function actually gets extremely small, which is we just loop through the whole list of objects and we call draw. Now, like I said in the last episode, we are always building on the previous episode. So in the next episode, we're going to build on top of this, because the next step is to define what I call a scene. And a scene is basically a collection of course, generic items. So you can have a scene for the title screen of the game. You can have a scene for the high score of the game, and then of course the scene of the gameplay. And based off which scene is the current scene, then that's the one that gets drawn, and the scene has an update. So basically, when the update gets called, it updates all the generic items in the list. Then it draws all the generic items in the list. This way, figuring out what state your game is in, like high score, or menu options, or game settings, or the start screen or something like that, it's extremely easy, and you don't have to do some nasty switch statement or anything like that, like I see most tutorials do. So play around with this. This episode will be uploaded to YouTube as well. If you like these series, then you should subscribe to the YouTube channel, and then you can follow me on Twitter as well. I know I haven't been keeping up to date with editing the Twitch TV information, but hopefully I will get that done later today, where I will have links to the previous episodes as well as links to the zip files or the OneDrive directories of the episodes. Until then, I'll see you tomorrow for the scene episode, which is episode 4, and hopefully right now you can see it coming together. Always baby steps, and then no big leaps. So I'll see you tomorrow. Bye.